right, Liz, we're gonna start over with the whole naming of the compound. All right. Now, I prefer using so this series of steps is from an old text called Chemistry Explained. But I really prefer how they present it because it's a lot simpler to follow. The book yesterday, yes, it's there, but I don't prefer it. So let's just go from there. So what they do is to tie in looking at structural isomers with actually naming these compounds. All right. So remember in the beginning, we started looking at straight chain compounds. So we just have carbon one after the other in a straight line, and then we attach the hydrogens to it. Or we attach the functional groups, putting in the double bond, adding the OH or the COOH. All right. Now, we can form structural isomers by doing one of two things. We can create branches, or we can shift around the functional group. I remember I said that it was really applicable to your alkenes and your alcohols, where we shift around the functional group, changing the position of it to form isomers. All right. Now your isomers contain the same number of atoms, meaning same number of carbon atoms, same number of hydrogen atoms. However, the structure is different. So when you need to draw the fully displayed structural formula, that is where you're going to pick up on the difference. You may not pick it up in your molecular formula. All right. So these are the steps I want you to follow, ladies. This is what I've been using for years. These are the steps that you're going to use to name your branch chain compounds, as well as compounds that have the position, the different positions of the functional group. So the first step is this. You're going to find the longest chain. So the first step, find the longest chain and name it as you would the normal on-branch chain. So the same thing that we will do, ladies, which is to count off how many carbons are in the chain, and then we know the prefix to apply. So if we have 5 carbons, we know it is pent. All right. If it is separated by single bonds between the carbon atoms, we know it's an alkane, and so we call it pentane. If we see a double bond in it, we know it's an alkene, and so we call it pentene. OH, you know, it's alcohol pentanol. But you count the longest chain. I remember now we said that a chain is usually written horizontally. Find the longest chain and you name it. That is the backbone. So you hear me talking about when you're drawing, you're to draw the backbone first. That is what we're talking about. The next step is to number the carbon atoms in the longest chain. And we're doing it both sides. Now, in some other readings, you may hear them say that you start numbering where you see the branch. So the side of the longest chain, where the side that has the branch the closest, then that is where you start numbering from. But if you have the larger chains, you're going to find that if they put it in the middle, it's not so easy to locate, okay, where's the shortest end from when I'm counting. So I would take this suggestion, which is to just number the carbon, going left and going right. Then, after you have numbered, you're going to name the branch starting with the lowest number first. All right. Now, what are branches? Branches look differently. One, they're going to be coming off the main chain. I would like to use that idea of a chain, right, and a pendant. So think about a pendant. So we can have this long chain going across, but once we have something stemming from it, this is your chain. This is your main branch. Now your main, I don't know, let me not use the word branch. So this is your, let me put backbone. Yes, that's the word I want to put. So that's the word I'm looking for. So the longest chain is your backbone. Once you have something coming off your backbone, it is known as a chain, all right, or a branch. So there are different chains. We can have chains that are made up of carbon atoms. So in this case, if my chain has one carbon atom only, then I call it methyl. So again, if I have this chain here, and on that chain, I have one carbon atom. So that chain is a carbon atom. See the chain there? And that chain, so my pendant has one carbon atom in it. Then the name of that pendant is called a methyl group, right? I remember now they call these alkyl groups. If it has two, then I call it ethyl. If it has three, then I call it propyl. So if I want a longer pendant on it, right? So I have my pendant and I want to make it longer. And that pendant has two carbons on it, then I call it ethyl. If the pendant has three carbons on it, then I call it propyl, right? Now, these will only form, ladies, especially with the propyl, if you have a very long chain, a very long backbone. The shorter ones that we will explore, I think you'll get up to ethyl, not so much a propyl. All right. Then we have another set of branches that can be formed. And these branches are with halogens. So if a branch, let's draw back my backbone here. So here I have my backbone, but my pendant that I'm hanging off has no halogens. I have a chlorine hanging off. Then that is now called chloro. That's the name of the pendant. That's the name of the branch. Chloro. If it is bromine, then it is bromo. If it is iodine, iodo. Two most popular ones, ladies, chlorine and bromine. These are the more all right. So you will get up you get mainly with chlorine and bromine. So these are the popular ones. All right. Now let's look at an example. I'm gonna really zoom this so you can see the diagram here. All right, let's look at this example. So you're given this structure and you're asked to name it. All right, let's go with the first step. The first step said that I'm to identify my longest chain. Now remember, the chain follows one behind the other, and the suggestion is that it should run horizontal. So let's find the chain. One, two, three. All right. So when I find the chain, I'm going to identify the name of the main chain based on the number of carbon atoms that are present. So if I have three carbon atoms present, ladies, and they're all separated by single bonds, what's the name of my backbone? It is now propane. All right. So I have three. My prefix for three is prop. Single bonds only. I know it's an alkane, and so it is propane. So that's step one. We're not finished with the name because remember now we have a branch. The next thing that you are asked to do is to number the branches. And we are numbering the branches left to right, right to left. So here we go. One, two, three. That's going left to right. Let's do the reverse. One, two, three. Now we need to identify the carbon that it falls on. But we can only use the number that is lower of the two. Which one is the lowest number that it fell on? In this case, zoom it somewhere for you, we are seeing that it falls on carbon number 2. Because we only have 3, it's smack in the middle. All right? So the obvious number here is 2. So we know the position of our branch. The next thing we need to do is to look at the branch. What is entailed in my branch? That's what I need to look at now. So here I have my branch coming off like a pendant. So here is my branch. I need to now look at, okay, what does my branch entail? My branch entails a single carbon atom with 3 hydrogens, CH3, which means that it's an alkyl group. An alkyl group that has a single carbon atom in it is known as methyl. So I'm going to continue with my name. Now I need to account for the position of where my methyl group is, and this is 2. So the name of my compound is 2-methyl propane. So 3 simple steps. The more you get familiar with it, is the quicker that you go. All right, ladies? So step number 1, find the longest branch. Step number 2, number the carbon atoms just to be certain of where you're going to identify the position. Find the branch group and name it. And then you put it all together. So putting it all together means that the position comes first, then the branch group, then the main chain. So there are 3 parts to this name. Got another example? This example is going to consider looking at with a halogen now. All right? For this example, ladies, notice that our carbon chain, see the carbon chain here? And it has 2 carbon atoms in it. Now, apart from it just having 2 carbon atoms, something else should jump out at you. You're going to notice that it has a double bond between the pair of carbon atoms. Right away, I can say, it's not an alkane anymore because alkanes don't possess a double bond. All right? What you have now is an alkene. An alkene that has only 2 carbon atoms in it. And so we know that the backbone is now ethene. See there? We do the same steps, ladies. Number going right to left, left to right. Now, what do you notice about this one? In this particular, you're going to notice that my group falls on this carbon here. That's where my branch is. It falls on this carbon. There are 2 numbers associated with this carbon. Look clearly. I have carbon number 1 and I have carbon number 2. My rule says I am to use the lowest number. 1, 2. The lower of the 2 numbers here would be carbon number 1. And so that is now the position for the branch group. So the name of this is 1-chloroethene. Chloro because the branch is chlorine. All right, examine this one carefully, ladies. We're going to try and identify our main chain. Is there a particular way that I can run? So I'm going to try, I'm going to show you. I'm going to run my highlighter through all the possible carbons. All right. So I can get it continuous this way. I can get it continuous this way. I can get my carbon this way. So there are three routes. I have my yellow route, my pink route, and my green route. All right. How many carbons are in my green route? See carbons. How many carbons are in my pink route? See any carbons are in my yellow route. So what you're noticing is that either route I take, my longest carbon chain has 3 carbon atoms. Are you seeing that? Now, for ease of naming this thing, we're going to keep the yellow route. All right? So we're keeping our yellow route. Good. Because again, it's easier when you look on it horizontally, because that's how we naturally read. You read from left to right. Now, the rule says that find the longest carbon chain, we just did it, and name the backbone. Our longest carbon chain had 3 carbon atoms in it. So what's the name of this, the backbone here? Propane. There we go. So that's the first step. The next suggestion is that we are to number our carbon atoms. Number our carbon atoms left to right, right to left. 1, 2, 3. 1, 2, 3. Can we identify the branches? No, ladies. Because this is my main chain, but I see some carbon atoms coming off it, I know that I have a branch right here. There is also another branch down here. So what do you notice? I have 2 branches. All right, and that is a possibility. I can have more than 1 branches. So I have 2 branches in this scenario here. Question, call this branch A and call this one branch B. I don't want, all right, look at branch A. Is there, can we name branch A? How many carbons are in branch A? A single carbon atom, so we have a CH3. So what would be the name of branch A? This one is methyl. But look at B. B looks the same thing as A, don't it?
Yes, miss.
Yes. So this is another methyl group. So right now for this particular compound, we have 2 branches and there are 2 methyl branches. So we need to account for that. Now, it doesn't make sense for me to write methyl propane, right? So because they're the same methyl group, to account for it, I use another prefix, and that prefix is di. So instead of me writing methyl propane, I am going to write dimethyl propane. All right? So I'm writing dimethyl propane. But remember, our name has 3 things. The name of the main chain, the name of the branch, and the position of the branch. So right now, we are 2 out of 3. We are missing the position of the branches. All right. On what carbon is branch number 1? Same 2. Good. So guess what? In order to account for the position of each branch, though it is in the same, on the same carbon, we write the numbers twice. That's the only thing we're going to write twice. So we write 2,2 dimethyl propane. Some other examples now. All right, so Now they want to throw in moving around the functional group list. So that is looking at making the branches with the alkyl group. Remember now we also said that you can shift around the position of the double bond. So let's look at butene. Now regular butene, the formula is C4H8. Because remember the general formula is CnH2n. So if I were to ask you to draw butane, you would have just drawn the 4 carbon atoms in the main chain. Draw the 4 carbon atoms in the main chain and then put the double bond somewhere. Now we're beginning to get more specific. Now, if you had drawn the double bond and you place it between the first 2 carbons, right? Here, such is the case. So if you drew it between the first 2 carbon atoms, this is where you put your double bond. We're going to do the same thing. We look at the number of carbon atoms in our longest chain. We see that is 4, so we know it's butene. But where is the position of my double bond? It's the same thing that we're going to do, ladies. We're going to number. So we have 1, 2, 3, 4. Do the opposite. 1, 2, 3, 4. Look at where my double bond is now falling. My double bond is falling between these. I have number 1. This carbon can be named carbon number 1. Or it can be carbon number 4, depending on how I'm counting. This carbon is carbon number 2 or carbon number 3, depending on the direction that I'm counting. But what does my rule say? My rule is very specific. My rule says I am to choose the lowest number. All right. In this case, we have 4 numbers contending with, and so it says choose the lowest number. That is what we're going to do. See my lowest number here? Lowest number is 1. So the name of my structure now is but1ene. An alternative to this, ladies, is actually just calling it 1-butene. And a lot of students prefer doing it this way. So instead of writing but1ene, I can write 1-butene. Still looking at butene, 4 carbon atoms in the chain. All right. However, let's say student B chooses to put the double bond in between these 2 carbon atoms instead. Where is it falling? Look at the numbers. I have 2, 3, 2, 3. I am to write it the lowest number. Our lowest number here is number 2. See there? So that's the lowest number that we have, 2. So this now becomes but2ene, or what else can I write it as? Excellent. I can name it 2-butene. All right, excellent work, ladies. Excellent work. Rewatch if needed. And